Alright, this is part 2 of our lesson on factoring by factoring out the greatest common factor and using the pattern of the difference of two squares. We've done these problems so far, and but now we're going to go ahead and hit up number 7. Alright, with number 7 I want to go ahead and show you a technique that you can use sometimes when the numbers are kind of big and maybe there are several factors to think about. Here's something that you can try to help you find the common factor. If you're not sure, you can just see it using your multiplication facts. And it is to write the prime factorization of each one of these numbers. Now, here's what I mean by that. Start with the 60. Let's go ahead and make a factor tree. You look at the 60, you see that's even. So that means you can write it as 2 times something. Obviously 60 is 2 times 30. Now please understand that 2 is a prime number. So that's done. We've got the 2. Now with the 30, that is not a prime number. It can factor further, so we keep going. 30 is even. As long as something is even, let's do the 2. So 30 is 2 times 15. Okay, again, 2 is a prime number, so done. Now the 15. 15 is odd now, so it's not going to be 2 times anything, but it's 3 times something. It is 3 times 5. Now both of those are prime numbers, so that means we've reached the end of the road. So the prime factorization for 60 is 2 times 2 times 3 times 5. Okay, so 60 equals 2 times 2 times 3 times 5. That's the prime factorization. Now let's do the same thing for 42. Okay, now for 42, that's even, so that's going to be 2 times 21. So 2 is prime. And then 21 is odd, but that's 3 times 7. And both of these are prime. So the prime factorization for 42 is just 2 times 3 times 7. Okay, so 42 is equal to 2 times 3 times 7. Now once you have two numbers in their prime factorization form, it's easy to find the GCF between them, because all you really have to do is highlight the GCF and multiply. So for example, you see they both have 1, 2 in common. Let's highlight that. They don't have any more 2's in common. They both have a 3 in common. Okay, so we've highlighted everything that they have in common. It's got to be pairs. So I'm not going to highlight this 2 and then both of these 2's. It's got to be pairs. So they both have at least 1, 2, and they both have a 3. So that means if you multiply these common factors together, that means the GCF here is 6, because the 2 times 3 is 6. Okay, so we just found that the GCF between 60 and 42 is 6. Now, could you have done that in your head using your multiplication facts? Well, yes. I mean, you can look at the 60 and you know that's 6 times 10, and you look at the 42 and you know that's 6 times 7, but maybe you wouldn't be sure that there wasn't something bigger. So I just wanted to show you this technique. It comes in handy sometimes. Okay, so anyway, we know now that 6 is the GCF between these numbers. So let's go ahead and pull that out and divide. The variables, what am I going to put right here, guys? Yeah, that's going to be x to the 5th power. Just go with the lesser amount of variables out front. Now we take our GCF and we divide with it. So 6x to the 5th power, 6x to the 5th power. 60 divided by 6 is 10. These x to the 5th powers cancel out. 42 divided by 6 is 7. These 5 x's will cancel out 5 of these x's, leaving 4 x's behind. Now, here's a hint that I should mention to you. If you really have pulled out the greatest common factor, there should not be any common factors inside the parentheses. So always look at your answer and ask yourself, is there a common factor in here? Is there anything that goes evenly into 10 and 7? Are there x's on both terms? There is no common factor. 7's prime, so this time we're good, but you should always check for that. Alright, number 8. Looking for that common factor, right? 18, 30, 12. Okay, all of these are divisible by 6. So I'm thinking that's the greatest common factor. If it turns out not to be, I'll see a common factor on the inside. I'll worry about it then. Now, the lesser amount of x's is actually the 4th power, so I'm going to go with the lesser. I feel a sneeze coming on. Excuse me, guys. I hope you said bless. I hope you blessed me just then. What happens if somebody doesn't bless you? Something bad is supposed to happen. I'm gonna have to look that up, but I'm sure you blessed me. That's why I'm okay. Now, divide. So I'm gonna do 6x to the 4th power. Division everywhere. Okay, so 18 divided by 6 is 3. These 4 x's will cancel out 4 of these x's, leaving 3 behind. 6 goes into 30 5 times. These x's cancel each other out completely. Okay, 12 divided by 6 is 2. And these 4 x's will cancel out 4 of these x's, leaving the 1x behind. So this is the answer. So again, always look at what's inside of your parentheses. Are there any common factors among these 3 terms? No. Prime, prime, prime. This term has no x's, so they don't have x's in common. So that means we did it correctly. Alright, let's find number 9. Let's see what's up. Alright, at first glance, I'm seeing all of these are divisible by 3. So let's go with that. The lesser amount of x's is just the 1x. So let's do that. So it looks like our GCF is 3x. Let's try it out. So 3x, 3x, 3x. Think. 9 divided by 3 is 3. This x cancels an x out, leaving 5. I see the minus sign. 24 divided by 3 is 8. This x cancels out one of these x's, leaving behind 3. I see you, minus sign. 15 divided by 3 is 5. And these x's right here cancel out completely. Thus, no x's. Nothing's common on the inside, so we're good. 9. Excuse me, I got the hiccups. Having all kinds of gastrointestinal problems. Number 10. Bam. What's common? When I look at 8, when I look at 16, I think 8. I look at 24, I think 8. I look at the 48, I think, 6 times 8 is 48. I'm seeing a lot of 8s going on. So I'm thinking 8 is the GCF here. So let's run with that. If I chose wrong, there will be a common factor still on the inside. Now, the variables. What is the lesser amount of x's? 5, 7, 2. 2 is the lesser. So I bring out x squared. Look at the y's. Y to the 3rd power. Just y. Y to the 6th power. Well, just y is the smallest, so I'm going to go with that. So this is my GCF, my friends. So let's divide. 8x squared y. 8x squared y. 8 x squared y. 16 divided by 8 is 2. These two x's cancel out 2 of these x's, leaving 3. 24 divided by 8 is 3. These two x's cancel out 2 of these x's. Oh, I forgot the y's. Ha ha. Let me leave space anyway. The y's. This y cancels out one of these y's, leaving 2 y's behind. Okay, there's the plus sign. 24 divided by 8 is 3. These two x's cancel out 2 of these x's, leaving 5 of them. These y's cancel out completely, so no y's here. 6 times 8 is 48, so 8 goes into 48 6 times. These x's cancel out completely, so no x's here. And this y will cancel out one of these y's, leaving 5 y's behind. Okay, now scan for common factors. 2, 3, 6. No, 2 and 3 are prime numbers, so we're safe there. Do all the terms have x's? No. Do all the terms have y's? No. So we're good. This is the answer to number 10. Okay, what about number 11? Number 11 has no common factor. Now I remember practicing something called the difference of two squares. Okay, that's where we did stuff like this. Okay, that's where we did things like, what did you say? X squared minus 49. Well, that's going to be x plus 7 times x minus 7. But all of these problems involve the difference of two squares. Okay, that means we were subtracting. Alright, we never had one that was addition. And that's because when it's addition, like x squared plus 49, that's unfactorable, or we say prime. Why did I use a lowercase I and all uppercase? I don't know, but I kind of like it. So I'm going to leave it that way. This is prime because think of all the ways that you might try to factor this. You might think, okay, if it's not, obviously it's not x plus 7, x minus 7. Okay, because that's going to make x squared, and then plus 7x and minus 7x, and 7 times negative 7 is negative 49, not positive 49. So we already knew that this is how you get x squared minus 49. So it couldn't be that. Okay, so what else might you try? A common answer is, well, let's try x plus 7 times x plus 7. So we'll get that plus. But the problem there is when you go for your double distributive property, x times x is x squared, x times 7 is 7x. But then 7 times x is another 7x, and 7 times 7 is in fact 49. Now when we have the difference of two squares, these would cancel out. But if you have the sum, you know, when you're multiplying a binomial, they're both positive, nothing cancels out. So you're just going to have 14. Let me use a different color. I say, boy, you're just going to have 14x right here. Alright, so you wind up with x squared plus 14x plus 49. Which is not what you started with. So, like I said, when it's a sum, when it's the sum of two squares, that is prime, is unfactorable. So that's what's going on here. Sum of two squares, it is prime, not factorable. Okay, now this is the difference of two squares, so we will use our pattern of something plus something, something minus something. 1 might look weird, but 1 is just 1 times 1. So it'll be 1 plus r times 1 minus r. That is all. Okay, number 13. 18, 45, 63. At a glance, it's popping into my head that all of these are divisible by 9. Let's see, 9 x's, 5, 3 x's. 3 x's, that's the lesser amount. How about the y's? 3 of them, 6 of them, 4 of them. 3 of them is the lesser amount. So let's go with that. Now let us divide, my friends. Let us divide by 9. X to the third power, y to the third power. Okay, 18 divided by 9 is 2. These 3 x's will cancel out 3 of these x's, leaving 6. These y's will cancel out completely. 45 divided by 9 is 5. These 3 x's will cancel out 3 of these x's, leaving 2. These 3 y's will cancel out 3 of these y's, leaving 3. 9 times 7 is 63, so kabam. These 3 x's will cancel out completely. These 3 y's will cancel out 3 of these y's, leaving just 1 y. So this is the answer. Quickly glance to make sure there are no common factors, and there are none. Let's see, 24, 32, 48. I know they're all divided by 4. How about 8? They're all divisible by 8. So let's go with that and see what happens. Now, x's, 8 of them, 6 of them, 4 of them. The lesser amount is 4, so I'm going to rock that. The y's, 4 of them, 2 of them, 7 of them. Always go with the lesser amount. So there you go. Now do your division to see what goes on the inside. Alright, 8 x to the 4th y squared. 8 . Okay, 24 divided by 8 is 3. These 4 x's will cancel out 4 of these x's, leaving 4. These 2 y's will cancel out 2 of these y's, leaving 2. 8 times 4 is 32, so there you go. These 4 x's will cancel out 4 of these x's, leaving 2. These 2 y's will cancel each other out completely. 6 times 8 is 48, so there you go. These 4 x's will cancel each other out completely, and these 2 y's will cancel out 2 of these y's, leaving 5. Scan across here to see if there's a common factor. If there ever was a common factor, that would mean we didn't pull out enough. But 3, 4, 6, nothing divides into all of these. 3 is prime. There are no variables in common, so we did the right thing. Alright, now for this one there's no GCF, but luckily this is the difference of 2 squares. So we are going to use our difference of 2 squares pattern that we have memorized, and we are going to factor these by splitting these perfect squares right down the middle. 121 is 11 times 11. Of course, t squared is t times t. And then we know we're going to have one of these will be plus and one of these is minus. That's how the middle terms get canceled out. 81, of course, is 9 times 9. And then u squared is u times u. So 11t plus 9u, 11t minus 9u. That's the pattern of the difference of 2 squares. Number 16 is also the difference of 2 squares. The 9, 16, both perfect squares. So let's knock this out. There is no common factor, so luckily we have the difference of 2 squares. So looking at the 9, that's going to be 3x times 3x to make 9x squared. And we know it'll be a plus and a minus. And then 16 is 4 times 4. So kabam. Guys, I hope this video was helpful to you. and we'll surely see you on the next video.